So let me show you how we actually write Agda programs. So we start off where we left off, except that I've inserted some more things. Let's talk through these first. So the first one is another data type declaration of the disjoint union of two types. So again, we have two parameters a and b, and we read this as a plus b, and it has two constructors, which says that the first one says that if you have an a, then you have an a plus b, and the second one says that if you have a b, then you have an a plus b. So what we have here is a way to put together things from a and things from b, and we can inject a's and we can inject b's into this thing. And I've used the same name as in the standard library, which we'll look at later. So there's this funny little U with a plus in the middle. And a good thing to know is that if you see a symbol in an Agda file and you don't know how to type it, which happens surprisingly often, then you could put the cursor on the symbol, then you go to the Agda menu and you ask for information about the character at point. And then you get a lot of information, most of it which you don't care about, but there's also the to input category, which tells you what you need to type in order to do this. So here we see that in order to type this funny character, you could either type \union or u plus or u plus. So that's good to know. Type this as \u plus, for example. So that's a data type, which we're going to use a lot. And here's something new that we haven't seen before, which is a record declaration. So in order to give a data type, we give its name, its parameters, and list all of its constructors. And a record is kind of the dual of this, where we still give its name. So here the name is times, which we type as \tines. We have two parameters again, a and b. We give the type of the whole thing, so this type is just set, and then we give some information for the record. So the first thing we give here is the constructor used to construct things. So I'm calling this just comma with two places for arguments before and after the comma. And then in order to give a record, we have to give the fields of the record, which we do with the field keyword. So in this case, I'm saying that the times record is given by giving a first projection and a second projection, where the first projection must have type A and the second projection must have type B. So this is the type of things where you have something from type A and something from type B. And then I open the record, which means that I don't have to prefix all the things with the name of the record, and I can just call it proj1 and proj2. And again, I've used these names because they occur in the standard library, like we see later. So this is just giving us something to play with for the rest of this file, but these are very useful things that we use a lot. So let's see. We want to define this function called swap, which takes two types a and b implicitly, so we don't have to care about them, and then it's taking something of type a times b and giving us back something of type b times a. And I haven't given a definition of this thing yet. I've just written a question mark, and I'll comment out this one for now. We can get back to it later. So I've just given a question mark, and if I now load this file, Control-C, Control-L, then this question mark turns into a shed, which is a little hole that we can interact with. And it represents a hole in the program where we haven't filled in everything yet. So we see that this shed has been labeled shed 0, and down here in this buffer we see all the goals, so we see all the types of all the sheds that we haven't filled in yet. So we see that this particular one, we have to fill in something of type a times b to b times a. So the first thing we can do is we can introduce an argument, because we are taking one argument that's supposed to produce one result. So let's call this x. Put it on the left hand side. We could also put a lambda in the hole, but I'll put it on the left hand side, and then I reload the file. So Control-C, Control-L, and we see that now the goal of the hole has changed. So it's not the function type anymore, it's just the result. And if I put the cursor in the hole and I do Control-C, Control-Comma, then I get the goal and the context of the thing. So you can also get this by right-clicking on the shed, and then you see all the different arguments you can see here. So control C, control comma is the goal type and context. So you get the type that you have to fill in and all the things that you know. So we know that we have an X of type A times B. Okay, so how can we possibly make progress? Well, we could pattern match on this X. So let's do that. And we do that by doing a case. So control C for case. And if I do that, then Agda is asking me what variable do you want to case on? And I want to case on X in this case. So I enter X and I press enter. And then Agda will do the pattern matching for me. I say that, well, X was of type A times B, and the constructor for this thing is called comma, so it has to be something, comma, something. And then it's chosen particularly bad names for these things, ploy 3 and ploy 4. So often what you have to do is you have to go back and rename these. So this first argument is of type A, so I'm going to call it little a, and this second argument is of type capital B, so I'm going to call it little b. And then I have to reload to make sure that Agda knows that I did this change. And if I now do control C, control comma again, I can look at the goal, and I see that the goal is the same as before. Still have to produce something of type B times A, but now my context has been more refined. So instead of just having an X, now I have a little a of type A and a little b of type B in my context, which is this A and this B. Right. Okay, so in order to make progress, I have to introduce something of this type. So I could even ask Agda if Agda has any idea. If I do refine, and there's only one possible way to go forward, then Agda will do that thing. So if I do refine, control C, control R, then Agda will see that the only way to construct something of this type is to use the constructor. So Agda says, well, no matter what, it has to be the constructor applied to 2 arguments. So now we have 2 sub-goals to fill. We have to fill in the first argument here, and we have to fill in the second argument. And we see that for the first argument it has to be a B, and for the second argument it has to be an A. So if I look at what I have available, I see that I have exactly one B available. So I can put that in. So I type in a B, and then I do control C, control space for giving this B. So let's give. And similarly here, I have to produce an A, and I do have an A. So I can do an A, and then I can do control C, control space. And if I reload the file, I see that everything is fine, and Agda says that it's checked and happy with the file here. Okay, so let's do one more. This one is called distribute. Okay, so I comment it out again, or in rather, and then I reload the file, and Agda gives me a hole. And again, we see that we have to give something a function type, so we can introduce an argument on the left hand side to call it X. And the only way we can make progress is to pattern match on this X. So I'll do control C, pattern matching on X. It gives me the terrible names again. I'm going to call this X and Y before I know what they are, because now I'll go to the shed, I look at the context, and I see that X is of type A. So I'll rename this A for my own sake, and Y is of this union type. So it's either a B or a C. Okay, so I can pattern match on the Y again, and it will give me 2 cases. It's either the first constructor or it's the second constructor. And if it's the first constructor, then this X is of type B, so I'm going to rename it to B. In the second case, this X, check just in case, this X is of type C, so call that C. I reload every time I rename something on the left, and then I can see. So now we actually have to do something. And what we have to do, we have to produce something of this type, given that we have these 2 things. Okay, so we could try to refine again, but now Agda tells us that Agda doesn't know which constructor to use, because we're trying to introduce something of this data type, the plus thing, but this data type has 2 constructors, so it's not obvious which one to use. We actually have to think a little bit. So let's see. We have an A and a B, so we can introduce something on the left, but we don't have a C, so we can't introduce anything on the right. So here we should probably introduce something on the left. So we do that by saying, okay, I want to use this constructor, but instead of giving everything in one go, I can put in another question mark, and if I give this, then I still have to fill in that question mark, but I can do that step by step. So here I have to produce an A times B. Now I can refine. Here I have to give an A, I have an A. Here I have to give a B, but I have a B. So happy. And similarly here, let's see what we have to do. Well, we have to produce either this or that, and we don't have a B, but we do have a C, so this will probably go on the right hand side. So this is an image 2 of something. This is a pair of something, so it's definitely this. I can refine. There's only one possibility. Here I have to give an A, but I do have an A, and here I have to give a C. I do have a C. I reload, and then again I see that Agda is happy because it says checked. So this is how we do a lot of our program in Agda. Instead of just writing a big program and then submitting it and hoping that everything is fine, we build it up step by step, and we get a lot of help along the way because we can ask for the types of things that we have available to us, which is a great help.